Hello everyone. Today we are discussing the chapter 2 physics part 1. In this chapter 2 we have discussed the basic fundamentals. After that we are going to discuss the electric potential at a point P, the distance r due to the charge Q. See what is that condition. We will imagine the origin charge, positive charge here. From this point we will assume the point P. So here we are calculating the potential. Potential means to say that V. So V यहाँ पर हमें calculate करना है. The distance from this charge to point P is R. Now let assume that a charge is coming from infinity is called Q naught, or you can say the test charge, which is also the positive one also. The distance from this origin charge of this charge is let x. Let x. The distance from this point to this point is x. What will happen? What are the scenes to be take place during this motion? We know that it is coming from infinity, so there is no potential at that point. But whenever it comes to the electric field of this origin of charge, it feel some type of force. This force is one to be repel itself, but some external agent apply the force over there to move it towards that charge. Due to this charge will displace a little bit. You can say that dx. So dx amount of displacement is take place due to that external force agent. So that displacement and the applied force will comes in the form of work done. So that work done, what will it happen here? See this one. So when that charge comes to this point, there is a force between them. So that we can say that Coulomb force 4 pi epsilon naught q1 q2 upon r square. So here our q1 is q and q2 is our q naught. So that is our force present between these two charges, and we have to work done against this force, or you can say that we have to apply at least this much of force. So amount of work done we can do here. So small amount of work done gives the small amount of displacement here. So here we are taking the displacement in the direction of this one. So we can say that the x is reducing, x is decreasing. Due to this reason, dx will come as a negative displacement. So we put the value of f here, and we are able to find out the small work done over this test charge due to the presence of this origin charge. So this is our small work done. Now what we will do? We will integrate it to find out the total work done. So total work done over that charge is capital W, and that will becomes after the integration, and the integration process is what? 1 upon 4 pi epsilon naught q1 q2 upon r square. Now see that r square, what we have done, we have not put it here the distance r. The r distance is here is x. So we will make it correction here. So x square will be the distance of force, and here also the x square will be the distance between two charges. So here the x square will come, and minus dx will remain as it is. So constant terms we will take it outside, and remaining terms will remain as it is. And now what is the going on there? What is the limitations of there? We are coming from infinity, and we want to reach that point P, which is having the distance r from the origin charge. So we are coming from infinity, so it is our initial, you can say that, limit, and the final limit, or you can say the final position is r. So in these boundaries we will try to do the calculate the total work done. So W, now the constant term will be come out 4 pi epsilon naught q1 q2. So these are the terms which are coming out, and what will happen? Integration from infinity to that point r, and as well as that what? That x square will be over there. So the power will become negative 2 and dx. So the differentiation or integration take place with respect to that dx, यानी कि से x के respect में. Now W. Now we will do the integration with respect to d. So what will happen? 1 upon 4 pi epsilon naught q, यहाँ पर q naught है, upon 1. What will happen here? Here happening is take place like this way. Then x minus 2 plus 1 and minus 2 plus 1, lower limit and upper limit. Now W 1 upon 4 pi epsilon naught, that negative will be come out and make it positive. So initially we have negative and then negative will be coming from here also, q naught. Now what will happen here? What will happen here? Here the after subtraction we get the minus 1 and the minus terms will come from this one also, that minus 1 is there in the upper limit and lower limit. That minus will make the positive, this total work done. The total work done become positive now due to this coming minus 4 pi epsilon naught. After this what will happen? Q naught, and we will try to put the limits here, upper limit and lower limit in this x square. So x square is basically 1 upon x. 1 upon x, you can say that upper limit is r. So 1 upon r minus 1 upon infinity, this one. So what will get? We will get 1 upon 4 pi epsilon naught q naught, that only 1 upon r remain left, and we will multiply inside this. We got the value 1 upon 4 pi epsilon naught q naught divided by r. So that is the electric potential, or you can say that work done. No, it is not of electric potential. We know the definition of electric potential. What is the definition? According to the definition, वर्क डन जो होता है, दैट यू कैन से दैट इलेक्ट्रिक पोटेंशियल जो होता है, द अमाउंट ऑफ वर्क डन ओवर ए टेस्ट चार्ज. So we will put the value of W here, okay, by putting the value of W here, by putting W in above equation. What will happen? So we will put it W here. So what will happen? The things will like this, then Q naught will remain as it is, and we will replace the W with this value 1 upon 4 pi epsilon naught Q naught divided by r square. So Q naught will be cutted down, Q naught. The remaining things are, the remaining part is that capital V, or you can say the electric potential, is equal to 1 upon 4 pi epsilon naught, because our charge is placed in the free space, or you can say that vacuum. And finally we got the answer is that this one. So this will be the potential at distance r of Q. So this will be the potential at distance r of Q. तो at distance r पर हमारा जो चार्ज Q था उसका हमने पोटेंशियल कैलकुलेट कर लिया. थैंक यू वेरी मच.